It's 3 o'clock, and I believe in starting promptly, so let's do this. So if you come here to see Worker Threads Crash Course, you're in the right place, and thank you, but I do question your judgment because Joy Chung is giving a talk in the other room about how Node bootstraps itself, and she's awesome, and it's going to be an amazing talk. And it's totally where I want to be right now, but I'm here. I'm happy to be here too. I should also, but if you want to leave now, you do, because I've insulted you, you totally can. This is also probably going to be less of a crash course and more of a introduction, but you know, not so gentle introduction. I don't know. We'll see how this goes. Anyway, you've made the wrong choice to be here, so hello, friends. Thank you. And I talk fast. I'll try not to, but actually I won't try not to because I have a half hour, and I ran through this talk about an hour ago, and it was way over. So I cut a bunch of stuff out, mostly jokes, though, so don't worry about it. It just won't be as funny as I wanted it to be, but hopefully I'll have as much material. My name is Rich. I work for the University of California at their San Francisco campus at the library. Right about now is when I imagine people going, he works in the library? What is he doing here? In sort of a Jim Gaffigan voice. That just makes me relax and feel good about things. But anyway, as it happens, I do a lot of work on Node Core. And I'm also the author of a rock opera about a steakhouse. I don't know if the sound on this is plugged in, but let's see if this works here. I don't know. Okay, so it's coming out of the projector, I think. Okay, cool. So anyway, I didn't come here to play examples of the rock opera, but but I did want to point it out because all the like links to blog posts and documentation and videos and stuff are at palsfamilysteakhouse.com. I don't think I have a link to the slide deck, which I guess I'll add after I'm done here. Okay. Anyway, but I'm not here to talk about that stuff. I'm here to talk about Node. But first, some disclaimers. The views expressed are my own and not necessarily those of my employer. That's a pretty standard disclaimer. The views expressed are my own and not necessarily those of Node. There are a lot of other people involved in Node. A few of them are here right now. Naturally, we all don't see everything the same way, hence this disclaimer. With that out of our way, Node. Hey, have you heard about worker threads? They were introduced in Node 10.5.0, but required a command line flag to use in that version. So use Node 12 if you don't want to use a command line flag, which you don't. Specifically, use Node 12.11.0 or newer, although I don't think there is a newer version in the 12 release line. There's 13 dot as well out. But anyway, that's the first version. 12.11.0 is the first LTS version where support is officially stable rather than experimental. So, yay. Oh, no, it's 12.13.1 because at the time of this writing, it's the most recent. Yes, not 12.13.1 is the most recent. Great, okay. Super, so anyway, worker threads. Hey, what are they? So they're kind of like web workers, but different. For example, if you're used to web workers, there's shared workers. No such thing here, but they're also kind of like threads in other programming languages, but not. If you've used threads in other programming languages, cool. If you haven't used threads in other programming languages, cool. It's going to be fine. Don't worry. So JavaScript, right? We all love JavaScript, and we all know JavaScript is single-threaded. Even if you have no idea what that means, before you saw the slide, there's a 100% chance that you've heard the phrase JavaScript is single-threaded. Because JavaScript is single-threaded, arguably. I actually don't want to have that argument, though. So the point is that your code can do one thing at a time. So it's why this program never exits. There's only one execution thread handling this code. So the code in the set timeout, which would break us out of the while loop, never gets to run because the code in the set timeout won't run until the while loop relinquishes control of the event loop. So this is going to run forever, or until you hit Control-C, or until you turn off your computer, or whatever. But it won't exit cleanly, and whatever causes it to exit, it's not going to be that set timeout. This is called blocking the event loop. If you already understand what that means, great. If you don't, trust me and look it up later. There are some good YouTube videos of talks about it. My favorite is What the Heck is the Event Loop Anyway by Philip Roberts. I think that was a JSConf.eu. I don't know. Anyway, there's a link at palsfamilysteakhouse.com. Now, you may be thinking, hey, this is cool and everything, but Node is asynchronous. I don't really have to worry about this blocking the event loop stuff. You're probably actually not thinking that, or you wouldn't be here. But anyway, Node can do many things at once, like handle multiple simultaneous HTTP requests or read multiple files. And that's true, but it's mostly true for input-output, for I/O. If you're doing, say, data science-y stuff or graphics processing or something that's CPU intensive, then let's just say the default state of things is not as asynchronous. Prior to worker threads, the usual way people would offload CPU in a non-blocking way in Node was the cluster module. And if that's working for you, great. But here's the thing. Cluster spreads your workload out across multiple node processes with independent memory and so on. So sharing large amounts of data is often problematic, and each process consumes the full amount of RAM required by node. This can be inefficient, although again, if it's working for you, then great. But it doesn't work great for a lot of things, and even for things that it does work for, worker threads will often be better because worker threads are more lightweight and they are better at sharing data. So let's dive in. Here's a hello world example, and we're going to go through it step by step. The first line pulls in 3 things from the worker threads module. It pulls in the worker class, the isMain thread boolean, and the parent port object. The worker class will be familiar to you if you've used web workers. If you haven't used web workers, there's a great blogger about the worker class, and that's Karl Marx. But we'll explain the worker class along with isMain thread and parent port later. Just know that they all came from the worker thread module. And we'll start with isMain thread. We use it to make sure we're not inside a worker thread. We're checking that we're in the main thread so that we know it's OK to launch a worker thread. If we didn't do this check, then this code might launch a worker thread that launches a worker thread that launches a worker thread ad infinitum, or until you run out of stack space or something. Anyway, I don't know what you'd run out of, actually. That'd be a good experiment. Anyway, this kind of check is usually only necessary when the code for the worker thread and the code for the main thread are in one file, which is probably not what you want to do but for production code, but works great for a hello world example. So there you go. So we know we're in the main thread, so what we're going to do is create a worker thread. So we use the constructor for the worker class. That's what new worker is, right? And we pass it underbar file name, which, as you probably know, is the special node variable that contains the name of the file currently being executed. And if you didn't know it, now you do. You can create a worker thread to run any JavaScript file you specify. So here we're specifying the file that's currently executed. But you can also pass a string path to any file. Or you can also pass in a string containing code to be executed. Although to do that, you need to pass a second argument to the constructor that tells it that you're doing that. I tend to avoid that because string as blob of executable code raises the same kind of hives that it might raise for eval, because that's basically what it is. But it's an option if it makes sense for your use case. So we're creating a worker. Now let's listen for messages from the worker. This is the usual event listener syntax in Node. Remember, we're in the main thread still, not the worker thread. We're listening for message events on the worker we've created, and when we get one, we're going to use console.log to print the message. And that's it for the main thread. Remember, we were in an if block that checked if we were in the main thread, so now let's use else and do the right stuff for when we're in the worker thread. And the only thing we're going to do is use parent port to send a message using its post message method. In the main thread, parent port will be null. But so if we want to send a message to the worker from the main thread, we use the post message method that's on the worker instance. But in a worker thread, parent port.postMessage can be used to send messages to the main thread. So let's use it to send a message that says hello world, and that's the end of the file. You'll remember that in the main thread, we had a listener for messages from the worker, and that listener prints the message. So if you run this file, it will print hello world. Not terribly useful. There are much easier ways to do that, but it does introduce the very basic concepts of worker threads. So now let's do something just as contrived as this, but more interesting. Perhaps you remember the game 6 Degrees of Kevin Bacon. If not, it's simple. Given the name of any actor in a film, your job is to connect them to Kevin Bacon in 6 or fewer steps in the following manner. Let's say you are challenged to connect Katy Perry to Kevin Bacon in 6 or fewer steps. Katy Perry was in Zoolander 2 with John Malkovich. And John Malkovich was in Queen's Logic with Kevin Bacon. Boom, Katy Perry to Kevin Bacon in 2 steps. I've seen neither of those movies. There are already websites that solve 6 Degrees of Kevin Bacon by using IMDb data. Several years ago, I wanted to do this for musicians playing on recordings of individual songs. So I made a site called Music Roots, but it's been broken for a long, long time, so let's fix it. First, surprisingly, there's no usable database available for what musicians play on what tracks. A lot of people think AllMusic has it. AllMusic has album data, but not track data. A lot of people think MusicBrainz will have that information, but it has artist data, not individual data. And a lot of people think Discogs has that information. Discogs just copies whatever on the album sleeve, which means that, for example, it will tell you that Rudy Sarzo played bass on Ozzy Osbourne's Diary of a Madman. And as everybody knows, he did, and he was just in the credits. Lee Kerslake played drums, and Bob Daisley played bass. That's the end of Ozzy Osbourne information for this talk. But y'all know just a little bit more now about Ozzy Osbourne. So anyway, that brings us to Wiki Data, which has some data along these lines, but less than you think. And that's cool. It's Wiki Data. Everybody can add information to it, but it's also very, very, very unusably slow for the many, many queries we'll need to make in our searches. So I built my own database and published it. It's very incomplete, but it'll do for here. And I also built a rudimentary little visualizer for it, which we might get to later. I don't know. So in order to solve these things, we could use BroaderFirst Search. I am now about to give the world's worst overview of BroaderFirst Search. Here it goes. Let's go back to connecting Katy Perry to Kevin Bacon. Step 1, is Katy Perry Kevin Bacon? That's a JavaScript triple equal there in the middle. The answer obviously is no, don't be ridiculous. Step 2, find everyone that was in a movie with Katy Perry. Do any of those people happen to be Kevin Bacon? The answer is no, it includes John Malkovich and other people. Step 3, find everyone that was in a movie with any of those people that were in a movie with Katy Perry. Do any of those people happen to be Kevin Bacon? The answer is yes, so we're done. Congratulations, you've just witnessed the worst explanation of BroaderFirst Search ever. Now let's do a slightly better explanation. This will be the second worst explanation of BroaderFirst Search ever. We're going to connect Katy Perry and Kevin Bacon, but this time not through movies. This time let's do it through music. Kevin Bacon has a band with his brother Michael Bacon. The band is called the Bacon Brothers, and I'm not making that up. Fun fact, as you can see in this photo from Wikipedia, Michael Bacon's nose has never been successfully photographed. So let's see if we can connect Katy Perry to Kevin Bacon via music. So step 1, is Katy Perry Kevin Bacon? No, get out of here with that nonsense. So here's a visualization of Katy Perry in the middle and everyone she recorded with on her album, One of the Boys, which I'm sorry to say is the only Katy Perry album that I have in the data set. You can open a pull request to fix that if you want to correct this horrible injustice. Anyway, Katy Perry is that circle in the middle, like I said, and each circle in the surrounding ring is someone who is one step away from Katy Perry because they played with her on that album. So somewhere in there is legendary session hornman Jerry Hay, there he is. There's also Eurythmics guitarist Dave Stewart at the bottom, who goes by David A. Stewart because literally, and I'm not making this up either, there are too many Dave Stewarts out there. There's a David N. Stewart, and it doesn't matter. So notably absent from that ring, though, is Kevin Bacon. So now imagine we take each of those circles in the ring around Katy Perry, and we find out everyone who is recorded with each of these people. We would take all those people and make an outer ring with circles of each of them. I didn't do that, but I did mostly because, well, for a lot of reasons. One, I'm lazy, but also because there'd be like way too many circles to fit on a slide. We're going to get to that in a minute. But yeah, the number of circles is going to grow exponentially or exponentially-ish with each ring, right? So you wouldn't want to see all those circles. But I did scrawl this ugly blue line to sort of represent that outer ring, kind of like Saturn, a little ring around the planet of Katy Perry. Anyway, I'm here to tell you something exciting about that outer ring, though. It totally contains Kevin Bacon. So that's basically BroaderFirst Search. Here are the results if you don't believe me. There you go. Yay, John Bon Jovi, who would have thought? Okay, so that is BroaderFirst Search. Let's implement it. No, just kidding. For purposes of this presentation, it's an implementation detail. There are trade-offs, various ways of implementing it, and I don't really want to get into it, and I don't have time. I'm talking way too fast as it is. But you can check out this repository for how I implemented it, as well as the other algorithms we're going to talk about in a little bit. The important thing is that our approach will keep the CPU busy rather than do a bunch of work up front. This is so that we can see how cool worker threads are, but it's also a legitimate trade-off one might make in the real world. It's not always worth it to spend time up front pre-processing your data if it's time-consuming, takes up too much storage, et cetera, et cetera. So here's what it looks like. Let's step through this. The first line gets all the tracks of the start person. Sorry for the long variable names, but it made sense when I wrote it in the repository. Anyway, let's say it's Aretha Franklin. We're going to put all the tracks in index 0 of an array of tracks for the start person. The index indicates how many steps we've gone from the start individual. And this line populates the corresponding array of individuals that are in the source of those tracks above. So in this case, it's an array of just one individual ID. It's just Aretha Franklin. For the 2 lines starting here, we're going to do the exact same thing for the target person. Let's say it's Carrie Brownstein. This line checks to see if we have a match by seeing if there are 1 or more tracks in both lists. Lastly, this while loop runs until a match is found. This line adds the individuals in the tracks that result from going out 1 more step from the start individual than we've gone thus far. So all the people on tracks with Aretha Franklin, then the next time it runs, it's going to be all the people on tracks with those people who are on tracks with Aretha Franklin, and so on, getting exponentially slower as more and more data is involved in deduplication and queries. So this line updates the matches list, so the while loop will stop if we found a match. So each time that last while loop runs, we remember each of these rings exponentially-ish, more work, longer paths will take longer, and there's a bit of a solution hinted at a use of an otherwise unnecessary array in that previous code. But first of all, let's check how BroaderFirst Search performs on my laptop. Here's a run with the results. It took more than 14 seconds just to do the BroaderFirst Search. That's a lot. We can do better even without worker threads by doing bidirectional search. Really quickly, here's how bidirectional search works. First, Katy Perry is not Kevin Bacon, despite the striking resemblance evident in that photo. Again, we look for everyone that is connected to Katy Perry and check to see if Kevin Bacon is in there. He's not. Now, we bounce back to Kevin Bacon, and we get everyone connected to him. We check to see if there is an overlap in the 2 sets of musicians. If not, then we do another query. We do one for Katy Perry's cluster of people, still no match. Do one for Kevin Bacon's cluster of people, still no match. Until there's a match. Now, so let's visualize it like this. Excuse me. That oval on the left is Katy Perry, and that oval on the right is Kevin Bacon. Katy Perry and Kevin Bacon, different people. There's space between them. So there's a bunch of little dots, but those are all people, just like Katy and Kevin. Anyway, those are all the people who played with Katy Perry. Still no Kevin Bacon. This is BroaderFirst Search. We're going to do another query. Now this query starts to get expensive. I didn't include all the dots that should be in there, but imagine like 800 times as many dots. And still no Kevin Bacon. We're going to do another query, and this one's even more expensive. But finally, there's Kevin Bacon. All right, so now bidirectional search would go this way. Let's check. Okay, all the people played with Katy Perry. Kevin Bacon's not in there. All the people played with Kevin Bacon. Katy Perry's not in there. Oh, look at this. We do one more query. Kevin Bacon and Katy Perry have some overlap. John Bon Jovi or someone is in the middle there. Dave Stewart, somebody is. Anyway, we're doing fewer expensive queries. We're doing the same number of queries because we have to do as many queries as it takes to get the number of steps to connect the 2 people, but we're doing less expensive queries. So let's see, if you don't believe, by the way, if you need big O notation to show how that works, or if my explanation sucks so bad that you have no idea what I'm talking about, there's a Wikipedia article. All right, how am I doing on time? I got 12 minutes. Okay, bidirectional search is just like BroaderFirst Search, right down to the comments, except for the contents of the while loop. So let's zoom in on that while loop. You can see that we do a BroaderFirst Search starting from the start individual. Then we check if there's a match, and if not, we do a second BroaderFirst Search starting from the target individual. And we repeat until we find some overlap. Holy moly, we went from 14 seconds to less than 3. It's awesome. But wait, this talk is about worker threads. Why be bound to a single thread? Rather than doing one BroaderFirst Search over here and checking, and then doing another one over here and checking, and then doing another one over here and checking, why not just run 2 threads doing simultaneous BroaderFirst searches, racing to see which one can return an overlapping individual first? So to create our worker threads this time, we are calling new worker again. And this time we're putting the worker code in a file called worker.js. There's also a new thing over there in the second argument, which is a worker data property. This allows us to provide the ID of the individual to start with. So worker data gets serialized and sent over to the worker, which then unserializes it into its own copy of the data, and which is basically what happens when you post message data as well. Now, worker threads can do this awesome magical thing where if you do things just right, you can share memory and also transfer memory buffers between the main thread and the worker thread. Sharing memory doesn't actually resemble sharing nachos like this, but I needed an image. So we're not doing this in this app. Worker data just sends a copy. But if your data is of a predictable size and format, and if there's a lot of it, Look at the docs for information on sharing memory or transferring it. It will be useful. In addition to the shared memory stuff, there's pooling. For this application, we always need 2 workers, one for Katy Perry and one for Kevin Bacon. And I don't care about the cost of starting one up. Just waiting until I need it and then starting one up. But in an application where your needs are more dynamic and you're trying to get the absolute best performance you can, you want to investigate having a pool of workers that you use as needed. There are NPM modules that can help you if you don't want to implement pooling yourself. So over in worker.js, reading the worker data value is done like this. You import the worker data property from the built-in worker threads module, then read the value of the ID key. We're going to context switch back to the main thread. We have an error listener that simply rethrows any unexpected errors from the worker. And we have a callback that we use when we receive a message from the worker. The index here is used to distinguish the results from Katy Perry's worker thread and Kevin Bacon's worker thread. So we might use 0 for Katy Perry's thread and 1 for Kevin Bacon's thread. Let's head over to the worker code again and see how the worker invokes the callback. So each worker is created, it grabs all the tracks the individual is on and sends them along with the individual back as an object to the main thread. That post message will cause the callback in the message thread to execute. So here's the callback. And again, the index is a value that lets us use the same callback for Katy Perry's tracks as we use for Kevin Bacon's tracks. We also get all the individuals from whom the list of tracks is derived, and we check to see if there are any tracks that are on both lists, thus indicating that our expanding circles are overlapping and we can stop. If we have a match, we call a function called done. We'll check that out in a second. If we're not done, we send a message to the worker to go get us another expanding ring of tracks and individuals. I'm not going to show the worker code that listens for the message, as it's pretty similar to what we've already seen. Plus, I feel like I'm rocketing through this fast enough. But if it gets the value next, it gets the next set of research results and sends them back to the main thread. Just know that to receive the message, the workers listen for the message event on the parent port object. But I do want to talk about that done function. It removes the listeners we have for both workers. And then it calls this method that's on all workers called terminate. And what terminate does is it ends the worker thread and returns a promise that resolves to the exit code of the worker thread. If we have cleanup code or whatever, and we want to make sure the worker thread's exited cleanly, we can put this in an async function and await the value. But in this case, we don't. I'm going to exit with an error code. It's going to exit with an error code because we're terminating it while it's running. We could also send it a message and have it end gracefully, but that's extra code and overhead we don't need in this case. This just says end execution immediately, please. But we could do something more elegant if we wanted to. And lastly, we print our results. So let's see how this performs. Remember, single-threaded BroaderFirst Search took over 14 seconds. Single-threaded bidirectional search under 3 seconds. Oh my gosh, it's less than 700 milliseconds now. I can't believe it. Unbelievable. This should be illegal. Now, I have to admit that the main motivation here was, as you might have picked up by now, wasn't really to talk about worker threads, as awesome as they are and as exciting as they are. It was to write a program to efficiently find out how far Pal's Family Steakhouse is from Lil Nas X. The answer, by the way, is 6 degrees. It starts with Lil Nas X, of course, and the first degree is Billy Ray Cyrus, who performed on Old Town Road. I was as surprised as anybody to find out that as recently as 2009, that's what Billy Ray Cyrus looked like. The second degree is country star Mary Chapin Carpenter, who along with Billy Ray Cyrus was on Dolly Parton's song Romeo. Dolly Parton gets her own slide because, you need to stop and just pay a few respects to Dolly Parton. The aforementioned Romeo was on her 32nd studio album. She wrote it, she produced it. People who aren't country music fans, and I'm not really one myself, but don't realize the extent to which she is in control of her sound and her career. She's a legend and a force to be reckoned with, so don't mess with Dolly. Also this, since we're starting from Old Town Road and everything like that. But the analogous legend and force to be reckoned with in Node is Anna Henningsen. She's the one most responsible for implementing worker threads, basically did it single-handedly. As far as all things Node go, it's extremely difficult to give Anna too much credit, so you should totally just start applauding right now. Yeah, that's it. She'll be one of the people on the Node Technical Steering Committee panel at 9 a.m. tomorrow morning, so check that out. Anyway, back to this nonsense. After Dolly Parton's track, Mary Chapin Carpenter goes through Saturday Night Live bandleader G. Smith and Tom Waits and a trumpet player named Chris Grady, who played on a track that I was on. Anyway, why should I restrict a fun of vanity exercises like this to me? You can head over to this glitch URL and try some stuff out. And since, you know, I do want to just take a, okay, let's see here. This is not working the way I expected it. Okay, let's see here. Yeah, so we can, yeah, so let's see here. You know, I don't know, let's try, I did Kermit the Frog because my daughter, it doesn't matter why I did Kermit the Frog. Earlier I did Kermit in front of Bob Dylan, but that didn't seem as much fun as some other things. What? The Pope? The Pope is, yeah, a musician. I don't think he's in the discography. But I don't know, we could try like Miles Davis or something. I don't know, let's try that. There you go. 4 steps from Kermit the Frog to Miles Davis. So anyway, you know, you search for people and they're not, and this is where the visualizer comes in. So, you know, here's Herbie Hancock and everybody he's played with. And then, you know, if you want to know what Randy Kerber was on, well, he was on this Herbie Hancock thing. But that's, you know, but if you want to know everything Herbie Hancock is on, there it is. You know, you get the idea. Okay, so anyway, so have fun with that glitch thing. Yay. Okay, present, please. This is going to throw me back to the beginning. Don't throw me back to the beginning. Yay, okay. So there you go. There's also a link at palestfamilysteakhouse.com. Thanks. Oh my gosh, I came in like 4 minutes under. That's awesome. Okay, yeah, wow, everybody stayed, it seemed like, and this was fun. I hope I didn't completely waste your time. Thank you very much.